This
what are the clock
conference will now be recorded.
and we also discuss like what are the commands associated to those characteristics, right? So this we discussed yesterday. Fine. So it seems you guys don't have any question from yesterday's session, right? Okay, so let me ask you a question. What is clock latency? Can someone say?
Before CTS, the delay between source to the clock definition point and clock definition point to the sync point. These are called the latencies.
Okay. So my question is, what is clock latency?
Sir, it is a amount of time required to complete the clock from clock source to the sequential clock pin of the element.
Okay. So you can say clock source to clock sync. Okay.
Yes.
And what are the components we have in clock latency?
Source latency and network latency.
What is source latency?
Source to the clock definition point. It is a source latency.
What is clock definition point?
It's a
Block
clock source point of
our block
our
definition point. Oh, sorry.
And what is the difference between latency and insertion delay?
So the network latency before CTS,
No.
it's called
My question is not network latency. My question is, what is the difference between latency and insertion delay?
So before CTS, we use the term latency, and after that, we use insertion delay.
How we define the latency? Define means based on how, like which kind, like what value we assign as a latency. That is estimated value based on the experience. Okay, and it will be around 10%. Depend again, it's vary based on the frequency and the technology node, but it will be around 10% to 15% of your time period will be your latency. Okay. Okay. Then can someone say what is a skew?
So T capture minus T launch means the difference between the delay between the insertion delay between the launch path and capture path.
Okay. Any other definition?
in arrival clock of the arrival clock between the two sequential elements.
Yeah, so difference in arrival of the clock into sequential element. If they are consecutive, then it's local skew. If they are globally, like the longest and shortest, then it's global skew. Okay, to find the positive skew and negative skew, always we consider the consecutive sequential element. And in consecutive sequential element, how we calculate the skew? capture clock network delay minus launch clock network delay. Correct? If that is positive, we have positive skew. If that is negative, we have negative skew. Okay.
So can you please repeat the definition for the skew?
1 minute. Can you see my screen?
Not
Sir,
yet.
not it.
Is it visible now? I shared. It may take some time.
Yes, sir.
So you can write out the definition. These PPTs are already shared. Skew is the difference in arrival of clock of two consecutive pins of a sequential element is called skew. Okay. Clock skew is the variation of arrival time of clock at destination point in the clock network. Difference in the arrival of the clock signal at the clock pin of different flops. Those are called skew. Okay. So what are the clock we can have in our design? We discussed few clock yesterday, right?
Synchronous clock or synchronous clock?
Okay. What is synchronous clock and what is asynchronous clock?
Same clock period synchronous and different clock period asynchronous.
Same clock period is synchronous, different clock period is asynchronous. Is that I explained yesterday?
No, sir.
Sir, in synchronous, the clocks will have different frequency, but they have uh, the base period of them of the waveform will be same.
Yes, correct. Correct. This is the definition. And the guy like who is saying that the synchronous clock will have the different will have the same frequency and asynchronous will have the different frequency. Guys, in this way, like if this will not work. Okay. And what is the another criteria? Synchronous clock will be generated from the same source. Asynchronous clock will be generated from the different sources. Synchronous clock will have the base period. Asynchronous clock will not have the base period. This is the two base point in between the synchronous clock and asynchronous clock. I explained it yesterday. I am making blunder. Okay. And what is main clock? What is source? Like what Clock means source clock. What is generated clock? What is gated clock? What is virtual clock?
The clock which is generated from the PLL, we can say it's a source clock. From the source clock, we can take the clock into divided circuit, so that will be a generated clock.
And
So
just
the
hold for a
gated,
minute. Just hold for a minute. Source clock, whatever you told from PLL, that is correct. But if I'll talk about the partition level, PLL cannot be in a partition. So in that case, clock definition point will
yeah,
give you a source clock.
okay,
Okay. So if in
okay,
partition level, if I'll discuss, clock definition point will give the main clock or
source
source
clock.
clock. Yeah, go ahead.
Yeah, so from the source clock, the clock will be divided, right? So the maybe based on our circuit, the generated clock we can generate. So that is a
Mhm.
generated clock. The virtual clock, so we don't have any physical clock available in the design, so we can say it's a virtual clock. So the gated clock, which is so for the power saving purpose, we have a gated clock, which is the one of the input will be the clock, and then other will be an enable. The output of the gate will be an gated clock. So so that's all.
Yeah.
Yeah.
Yeah, so gated clock, nothing but is correct. So enable and all that we will discuss in a clock gating. The concern here is the combinational cell and or cell if exists into the clock path, those are called the gated clock.
Yeah.
And the virtual clock is nothing but it will not exist physically into your partition. It will exist virtually into your partition. And what is the use of it? We use virtual clock to constrain our design, isn't it?
Yes.
Okay. So you were not asking the question, but you are not answering also, right? So guys, you know well what you have to do. I'm not going to say, but yeah, you know well what you have to do. You have to practice. You have to go to the slides. You have to put some more time and learn the things. Because see, once we started, it's not going to stop. And we'll check like what you understand and what you didn't understand. It's your job because you people are not a kid, right? Some people they're already working. Some people they're already completed their graduation. Some people they already completed their post graduation. So that was expectation we should also have from you. Okay. So we will start today. Okay. First, we'll understand the terminology. Mm, Can you see my screen?
Yeah,
Yes, sir.
yes.
Okay. So few things which we need to understand is so this is we what we will do is like when we discuss the static timing analysis, we discuss in between pair of flops on maybe sequential element. It can be register to register, it can be registered to latch, it can be registered to ICG cell, it can be registered to memory, or maybe latch to latch, or maybe uh, register to memory, or maybe any other sequential element we have in our design. Okay, so always whenever you will see like if we are discussing any concept of a static timing analysis, there will be a pair of flop. There will be a pair of flop, and all the game will be in between a pair of flops. So understanding from here is very important. So like you people are is the basic things you already know. Uh, yeah. So if I'll say in this diagram, this flop will be your launch flop. This flop will be your launch flop. This flop will be your capture flop. How we can say that this is a launch flop and this is a capture flop? Yesterday also we discussed depends on the data flow. So my data is flowing from here to here. So once if my data is flowing from here to here, then this guy is launching the data. That's why we are saying this flop as a launching. And this guy is capturing the data. So we are saying this guy as a capture flop. Now all the terminology associated to this will be launch, and terminology associated to this flop will be the capture. Here if you'll see, the clock which are going to the launch flop is called the launch clock path. Launch clock path. The clock which is going to capture flop is called the capture clock path. This is called the capture clock path because this clock is going to the capture path. If we have any common network in clock, that is called the common clock path. Any common network. If there is no any common network, and all the network which is associated to launch will be launch, and all the network which are associated to the capture will be the capture. But if there is any common clock, common network in terms of the cells, in terms of the nets, those will be called as a common clock path. And this point will be called as a common point. This point will be the common point. From this point, it will act as a launch clock path, and here it will act as a capture clock path. These two are also a part of both. Like it's a part of your launch also, and it's a part of your capture also. But later we will understand why we are so associated to this common clock network. We will discuss later. That is called the CRPR. There we have some funda to have some benefit in this. We'll discuss later. So this is called common clock. This point is called the common point. Okay. So this is the few terminology that we understand. Okay. What is setup timing and what is hold timing, guys? Can you give the definition? What is setup time and what is hold time?
So the minimum time required to, required before the active edge of the clock, that is a setup time. So the minimum time required, the data needs to be stable after the clock, after the active edge of the clock will be the hold time.
Okay. Okay. So that's correct. I will give you a practical example. We all are boarding the flight. So if you see, so if you have a flight at 2 o'clock, your boarding time will be somewhere half an hour or 45 minutes early, right? So this half an hour 45 minutes they are taking to make the settlement of your seats and everything. Just hold for a minute. So these are few terminology and definition wise, as he told, that is correct. So setup time is nothing but the example which I was giving is, you can assume the setup time is nothing but your boarding time. Suppose you have flight at 2 o'clock and they are saying that you have to reach early within half an hour, like your boarding will start from 45 minutes early. So maybe 1:15. So 1:15 to 2 o'clock is the boarding time. So in that they will give you seats, everything check and everything will be done, and everything will be set so that they can start the flight at 2 o'clock. That is called the settling time of the flight. Same way for your data, you are assuring that before arriving to the clock, my everything should be in a sync. My all the inputs should arrive. All my inputs should be settled before this time. So that's the intention is called boarding time, and here your setup time. So that boarding time 45 minutes is here setup time. Okay. So your amount of time synchronous input must be stable before the active edge of the clock. This is called setup time. And hold time is nothing but the amount of time synchronous input must be stable after the active edge of the clock. So hold time is nothing but my synchronous should be stable after the edge of the clock, because we don't know. So we don't know how much time your sequential element will take the data from input to output. My just maybe the chance that your data is transferring from input to output, and in between something has happened and your input got changed, and you are getting some and it's your like sequential element is going to the meta stability or something. So to avoid this, we are assuming that we are holding the input data as a stable, so that I should have the smooth transition from input to output. Okay, that is called the hold time. And setup time means the amount of time synchronous input must be stable before the active edge of the clock, similar to the boarding time. So before boarding time, all the passengers should reach. So they will start preparing the flight. Same you can compare with the data also. So data will reach before setup time so that they can start the transmission of data. Okay, so what we are doing is, while the timing analysis, we are converting, we are not converting, we are dividing the complete circuit into 4 category. One is input port to register, means input port to register. This is called first register to register, register to register. Third category is register to output port. So this is register, and this is the output port. So register to output port. And there is another category. Fourth is input port to output port. Input port to output port. These kind of paths are called as a feed through paths. As feed through paths, the paths which will not have any sequential element. It will have only combinational. That is called the feed through path or input input to output path. Okay, so your all the circuits of like the complete circuit will set in all these 4 category of path. There won't be any path which will be left beyond this. I will have res to res path, or I will have the input to res path, or I will have a res to output path, or I will have a path which will not have any resistors. So what are the paths we have? Input to reg, res to reg, res to out category of path. We will discuss one by one all category of path, like how tool does and what are the things which we need to understand to do this input to reg timing analysis, reg to reg timing analysis, reg to out timing analysis, and into out timing analysis. But steps associated to reg to reg path. Okay, so first we'll understand how to do the reg to reg timing analysis. Then we'll understand other category of the paths, how to handle it. While doing the timing analysis, we do two checks. One, setup check, another, hold check. So till now we discussed the setup timing, what is setup time, what is hold time. Now we are discussing the setup check and hold check. So if you'll see here in this waveform, it's very good to understand the setup check. So this is the clock. This is the clock we have, and this is my flip flop 1 pin. Flip flop 1 D pin. It means this is a flip flop, and this is a clock, and this is a flip flop D pin. This is the D pin of flip flop 1. So we have a data 0, and it's moving to 1, and it's propagating here. So what data I will have? What of data I will have as a flip flop? So whenever launch is will come, it will send the input to the output. Correct? Input data will be sent to the output, but it will have some delay. Data propagating from input to output will have some propagation. So with some propagation delay, my data will be available to the queue pin. So this is the delay. This is the delay we have. Correct? This is the data. So we send the data from input to output. My data is available here. Hello?
Sir, in between your voice is getting
Any
break, sir.
problem?
Not, yeah, did not understand, sorry. Voice was breaking.
Oh, okay. Is this fine? Is it breaking for everyone?
Yes, sir.
Yes, yeah, yeah.
Yes, sir.
Now? Mm-hmm. Am I audible now?
Yes, sir.
Yeah, yes.
Okay. So data will be, so this will be the delay, that is called the propagation delay of flip flop from clock to deep in cube. Okay. Now, once we'll have this data here available, it will have some combinational delay. What is that combinational delay? That delay will exist in between of the flop. I have one flop here. So this is launch flop, this is capture flop. Between there may be some combination. So it will also take some. So we have data here. It will have some this combinational circuit delay to reach to this pin. So I have this data. I have this much combinational delay to reach this point. This is called arrival time. So data will going to arrive at capture end this time. Means if you have to capture a flight, you have taken you started your journey. You have this path is nothing but a cab which you have taken from place to reach to the airport, and you reached at this time. This is actual arrival time. You reach to the airport. But when you are going to be inside the flight next clock, be inside the flight next clock. So when boarding will start,
Again breaking,
only
sir.
they will take you into the flight. So when this clock will come, only it will take. Hello.
Sir, again breaking, sir.
Any question?
So your voice is again breaking, sir.
Okay. Anyways, is it better now? Am I audible now, guys?
Yeah, yes.
Yes or no?
Yes, sir.
कुछ बोलो. Okay, fine. So this is the time where you arrived. Same way your data arrived here. You arrived early. You have to wait, or if you have access of the what, then you can go and have something in the lounge. But you will be going to captured when your next clock will come. This is the time where clock will arrive. This is the time, the setup time. So this is the setup time for this capture flop. This capture flop needs this much time to settle down data, like to take the data. So my all the inputs should be available before this time. So this time is not in my hand. This is not in my hand. I have a time till here. You reached early, so you are in safe side. One will come after this borderline. They won't take one after you after this borderline. This will not, it will not say this flop will not take this data. This I cannot, but what will happen? This is going to this. What is my rule? All the for the setup time. Okay, okay. It seems okay. Okay, I my is not clear to try something. Am I audible now, guys? Can anyone respond?
Yes, sir. Now you're
Yes,
audible.
sir.
Okay. So I was explaining the same thing, like the way we catch the flight. So same way. Suppose your data is coming after this borderline. This borderline nothing but my clock, and before clock my setup time. This is my setup time. This is my setup time, and this is a clock. So my data should reach before this borderline, right? So if data will come after this borderline, this is a violation of the rule, and it should report it as a setup violation. So which will be your violation if my data is coming after this borderline? This is my borderline, and this borderline is what we call as this borderline as a required time. So what is my required time? A time period minus setup time for flip-flop 2. So what is my flip-flop 2? My capture flop. So what is the required time? Time period minus this setup time for flip-flop 2. This will be the required time. And what is my arrival time? The actual time it can reach the data at the D pin of the flip-flop. It means capture flop. Time taken from data to reach the capture pin of the flop will call as a arrival time of the data. What is slag? Slag is nothing but required time minus arrival time. So slag is one term which is called required time minus arrival time. So if my required time is more than arrival time, my slag will be positive. So if my slag is positive, it means I don't have any violation. And when my slag will be positive, my slag will be only positive if my data will reach before this boundary. And if my data will come after this boundary, I will have more arrival time. Arrival time will be more, so required time minus arrival time will be negative. That will be called the negative slag. A negative slag, if we have a negative slag, it means those are the violations. Those will be reported as a violations. Okay. So do you understand the setup check timing?
Yes, sir.
Meeting is not recording. Meeting is not recording.
Yeah, I think
No,
initially
sir.
it's recording. Initially it's recorded. I think a few minutes back. I think it's got somehow not recording.
So do you guys need recording?
Maybe if anyone is missed, maybe it will be useful for them.
Let me check if I can do. I'm not able to find where to start the recording. Okay, maybe after sending it will come. Okay. I'm not able to find guys how to start recording. Maybe he is started. I don't know.
Yeah, okay, then
Okay,
fine.
so any confusion till here?
Yes, sir.
No,
Any confusion till here? Yes, sir means you have a question.
No, sir. Actually, in between, your voice was getting breaking, and you were explaining the waveforms. So, I did not get, sir. Like, so properly.
Okay, I will explain. I'll repeat again.
Yeah, sir.
So this is the launch edge, this is the capture edge, this is the clock, okay, and this is nothing but my launch flop, this is my capture flop. So when clock will come, my data will be sent to the input to output. That's the way flip flop works. Like, so flip flop works when clock will arrive, it will send the data from input to output. The job is done. Clock arrived, data sent to the input to output. Data is available at the output. Now what will happen? It will have some combinational delay because that combinational circuit will be exist between these two flip flops. So that delay will be add up and it will reach to the input pin of the flip flop 2. Input pin of the flip flop 2 it will reach. Okay.
Yes, sir.
And it will wait till clock will arrive. So data has started and it's reached to the D pin of the flip flop 2. This is called the arrival time. And what is my required time? Because this is my requirement. My data should reach before next edge and with this setup time. And as per the definition, all the inputs should be stable before this setup time. So this time is reserved for this flip flop 2. This time is not in our hand. So what is my required time? Time period minus this setup time is my required time. So what this is my requirement. What is my requirement? My requirement is this. All my data should reach before this boundary. Then only I will not have the rules violation. Then only I cannot have I will not have the setup violation. Because how we calculate the setup violation? To calculate the setup violation, we are calculating the slag. What is slag? Required time minus arrival time. So required time minus arrival time will be the slag. If required time will be more, arrival time will be less, then it will be positive. If it's positive, no violation. If it's negative, it is a violation. When it will be negative, if arrival time will be more than required time, it means data is coming beyond this boundary. That is not acceptable. That will be reported as a violation. Now it's your job to find how to fix it. This is all about setup check and setup violation. Is this clear?
Yes, sir.
Okay. This is nothing but setup check and hold check. So setup check verify that the data launched from flip flop 1 at time is equal to 0 arrives at the D input of flip flop 2 in time for the capture is at time same which I explained. If the data takes too long to arrive, it is reported as a setup violation. Same thing. It means if I have to do the setup check, where I will do the setup check? I will do the setup check at next edge of the clock. If I am launching data at this edge, I will do the setup check at this edge. Okay. And what is hold check? Hold check verify the data launched from flip flop 1 at t is equal to 0 does not get propagated so soon that it gets captured at flip-flop. At the clock edge, time is equal to 0. If the data arrives too soon, it is reported as a hold violation. Now we'll understand from this circuit. What is setup time? A setup time is my data should reach before this clock will arrive. Before the next stage of the clock will arrive at this capture end, my data should reach. That's called the setup check. What is hold check? In hold check, our job is to check that my data should not propagate so fast so that it will reach and overlap the previous data. Previous data only should get sent by this clock. My next data should not go and overlap this data. There should be some sufficient delay so that this is not going to hamper this guy. My data should not so fast so that the same clock, at the same clock, my new data is getting captured. So my data should not get captured at so early, and my data should not get captured with this after this time also. Both are violation. This is called timing check. In timing check, what we are assuring? We are assuring that my data should not get captured at the same age, but my data should get captured at the next stage. This is called timing check. The data should So what we do? Actually, it's still like I had some network issue. Okay. So in timing check, what is my intention? My intention is my data should not get captured at the same age, and my data should get captured at the next stage. There is two things which we need to understand in the timing check. One, my data should not get captured at the same edge. This check is called the hold check. And that if my data should get captured at the next stage. If it's not capturing, then it's setup violation, and that check is called the setup check. Setup check is nothing but my data should get captured at the next edge. This assurance is called setup check. And my data should not get captured at the same edge. This assurance is called the hold check. Is this clear to everyone? कोई तो कुछ बोलो.
Yes, sir.
Yes, sir.
ठीक है. So yesterday also we discussed like when we do the static timing analysis. So you can see here. This is the RTL, this is the SDC constant. We did the synthesis. After synthesis, we have gate level netlist unoptimized here. We did the logical optimization. So we have get level netlist optimized. So here after this we will take the physical design. This is called the logical design. Logical design will our clock will be ideal. We will not have the routing. We will have this DC. We will have the logical library. Using that we can do the static timing analysis before optimization, and we can do the optimization based on the validation which we can have. So that will be there here. Then we'll have the static time analysis after the placement, after the CTS, and after the routing. Here I will have the get level netlist that will be global routed. Here we'll have the get level netlist, real clock tree build up. And after the routing, we can do the static timing analysis, including noise, crosstalk, derates, everything. So get level netlist, real routing, real clock tree, optimized. Okay. Okay. So mm, mm, okay. So I discussed about the few terminology: required time, arrival time, slag, right? Required time, arrival time, slag, setup slag, hold slag, that we discussed, right? So we have a pair of flop. We have a pair of flop. Let's understand the terminology, how to find the required time and how to find the arrival time. So if we will able to understand how to find the arrival time and how to find the required time, then we can easily check that whether my timing is meeting my requirement or not. So as per our understanding, if we'll take this circuit, so setup slag, what is setup slag? Required time minus arrival time,
Arrival time.
correct? So now we will understand what is arrival time. Arrival time is nothing but data to reach the D pin of the capture flip-flop, right? Time taken to reach the data to D pin of the capture flip-flop. It means my clock is arriving from here. So this time, then it will take the data, send to the output, then it will reach the D pin of the flip-flop. Just hold for a minute, guys. I'm coming. So arrival time is, what is the journey of the time? Is nothing but it will start from here. It will reach to this clock pin, then clock Q, and then from this clock Q pin to the D pin of my capture flop. So this much time if we will add, then that time will be the data arrival time. So what are the components will be there in the arrival time? From here to clock pin of the launch flop will be called as the launch clock path, and we are writing as a T launch. In T launch, everything is T launch. For source clock, source latency, for network latency, everything. All the clock delay to this sync pin will be your launch clock path. After this, clock to Q delay. Clock to Q delay of which flip flop? Flip flop 1. T launch plus clock to Q delay of flip flop 1 means launch flop, plus T combinational. What is T combinational? From Q pin to D pin of the capture flop. Q pin to D pin of the capture flop, whatever the delay we have associated to the logic gate and the net delay will call as a T combinational delay. These three components will be a part of your arrival time. Correct? Now, what is required time? Required time is same way. This much time clock will take to reach the clock to the capture end. So this will called as a T capture. We do the setup check in the next edge. It means after a period. So plus time period, that is called the TP. And as per the setup definition, my data should reach before the settling time. That is called the setup time. Setup time for which flip flop? If you remember the circuit, this time. So the required time is nothing but a time period minus this setup time. So time period capture is nothing but a clock delay. Clock delay, time period minus the setup of flip flop 2. Clock to Q delay for flip flop 1. T setup for which flop? Capture flop. Is this clear? Arrival time, required time?
Yeah.
And if I have to find the setup flag, we calculated arrival time and required time. We will check required time minus arrival time. Well, if this is positive, no violation. If this is negative, no violation. If this is 0, no violation. 0 also is not a violation. Okay. So we understand how to calculate the setup flag. Can you see my screen? So clock buffer is giving a delay of 15 nanosecond. Data buffer is giving a delay of 10 nanosecond. You have T setup as 3 nanosecond. You have a time period as 50 nanosecond. You have 50 nanosecond as time period. This is your setup. You have a clock buffer. Each buffer is giving delay of 15 nanosecond. Data buffer is giving a delay of 10 nanosecond. And clock to queue delay is 15 nanosecond. Do you need anything else? No. We need to consider net delay as 0. All the net is not giving any delay. So we are considering the considering no net delay. Net delay is 0. Time period is 15 nanosecond. Setup time is 3 nanosecond. Buffer in data path is giving a delay of 10 nanosecond. Buffer in a clock path is giving a delay of 15 nanosecond. Clock to queue delay for flip flop 1 is 15 nanosecond. And you have to find a setup lag. Your time starts now. You have next 2 minutes of time to tell me the answer of setup lag.
So 17 nanoseconds, positive slack of 17 nanoseconds.
Okay, so we received the answer. Answer is positive 17 nanosecond. Everybody is getting same answer, or do you have another opinion?
Yes, sir. Post is
So anyone is getting other than this? So two people got positive 70 nanosecond. Other people, they did not get any answer, right? Okay, we'll solve this.
Same, sir.
What is arrival time? T launch plus clock to Q delay of flip flop 1 plus T combo. This will be my arrival time. I told you this is my T launch 3 clock buffer. 3 clock buffer will give a delay of, each buffer will give a delay of 15 nanosecond. So 3 buffer will give a delay of 45 nanosecond. Clock to Q delay is 15 nanosecond. In combinational, we have 3 buffer. Each buffer is giving a delay of 10 nanosecond. So that is called 30 nanosecond. If I will add, this is 60 and 30, 90 nanosecond. So 90 nanosecond is my arrival time. In required time, what are the components we have? T capture plus time period minus T setup. What is T capture? 4 clock buffer. Each buffer will give a delay of 15. So this is 60. Time period is 50 minus 3. So 107. 107. Now what is setup lag? Required time minus arrival time. So 107 minus 90 is equal to 17. Positive 17 is the correct answer. Those who didn't do, did you understand now? Okay guys, we'll take a break. We'll take a break of 15 minutes and then we'll continue. Okay.
Okay, sir.
Hi guys. Hope everybody is back.
Hello. Yeah.
Yeah. Okay, good. So we discuss about the setup slack, how to calculate the setup slack. Now let's understand how to find the hold slack. So where we do the hold check, we do the hold check at the same age, right?
Yes, sir.
So if I'll take, this is my register, this is my register, I have some combinational logic, I have clock, and we do the hold check at the same edge. This is the edge. Setup check here. We calculated the formula also. Let's check for the hold. So hold slack will be arrival time minus required time. Opposite of setup slack. Components of arrival time will be same. T launch plus clock to queue plus T combo. Difference will be in a required time. Required time we will have the T capture. It means clock and product will be remain same. But as we do the hold check at the same age, so we will not have the time period here. So time period won't be there. As per the hold definition, what is my settling time? Hold. And hold is coming after the clock edge. So here it will be plus T hold. So your required time will be T capture plus T hold. T hold of flip flop 2. Flip flop 2 is nothing but your capture flip flop. And arrival time minus required time will be your hold slack. Can you see my screen? Guys, can you see my screen?
Yeah,
Yes,
yes,
sir.
yes.
So what you have to do, you have to take the, here it's given minimum delay and maximum delay. You no need to bother about mean delay. There is a significance of mean delay and max delay that I will explain. Once I will explain, then you will understand. For meanwhile, I'm just using the diagram and few value. So for time being, just avoid the minimum value. I also like scratch those minimum value. Here the question is to find the maximum frequency. Okay. So, but I will give you time period. I need to explain how to find the minimum maximum frequency. Then you will understand. So time period is 20 nanosecond. Just everything is given. All the data, clock to queue, everything is given. You have to find setup slag and hold slag for this circuit. Time period is 20 nanosecond.
Both are positive. The setup is 5 nanoseconds and hold slag will be 9 nanoseconds.
Okay, so we got answer. Hold slag is how much?
9
9. Positive or negative?
positive, sir. And setup is positive 5 nanoseconds.
Setup is
5 positive 5
positive.
nanoseconds. Yes.
Okay, positive 5 and hold is positive 9. Okay. Any other answer, guys? What about other people? Did not get any answer?
So setup slack is 0.
Okay, another answer, setup slack 0.
So setup slack +5, hold slack is +9. It's correct. No, what first one?
Okay, okay, okay. Waiting for some more answer, guys.
Yeah, +5, +9. Yeah, setup and hold.
Okay, majority people are going with +5 and +9. Any other answer?
Five and hold slack is 9, sir.
Okay. So let's do for setup slack. We have to find the arrival time. What is the arrival time? T launch, that is called 2 nanosecond. Clock to queue delays 11 nanosecond. This net delays 2 nanosecond. This is inverter delays 9 plus 2. So how much it is? 26 nanosecond. Correct? What is the required time? T capture. T capture is 3 plus 9 plus 3. Time period is 20 minus setup is 4. So that's 15, 20, 35 minus 4. How much? 35 minus 4? 31. 31 minus 26 plus 5 nanosecond. So plus 5 nanosecond is setup slack. Those who are not able to do it, have you understand now? For the whole slack, arrival time will be remain same 26 nanosecond. What is the required time? Required time will be 3 plus 9 plus 3. That is T capture. Time period we don't have to take. That is 2 nanosecond. So that is 17 nanosecond. Travel time minus required time will be plus 9 nanosecond. That is correct. So plus 5 nanosecond and plus 9 nanosecond is the setup slag and hold slag based on our question. While doing the timing analysis, how we do the timing analysis of the design? We do the timing analysis of each and every raise to raise path and each and every into raise to out. Like whatever the path we have in a design, all the paths should be verified with the frequency. Okay, all the paths should be verified. So if all the paths I need to verify, then we have to find like how many paths we have in the design and whether all the paths are meeting the criteria or not. So generally few kind of this question will be, one is to find the frequency. No, one is to find the setup slag and hold slag. Another is they will give you everything and they will ask you to find the frequency. So we'll do some exercise to find the frequency of the circuit. Okay. Can anyone say that in the same circuit, the circuit which we had, what will be the time period for that circuit?
20.
20 is I have taken time period, right? Just forget that. You don't know the time period. Okay, so let me share this. What I told you to find the setup slag and hold slag with a given frequency of 20 nanosecond. T mean you no need to consider. Same thing, we're not considering. We'll scratch it. Now your question is, I'm not giving you time period. Time period is unknown. You have to find what should be the suitable time period so that this circuit will be operational. Can anyone do it?
Yes.
So can you please repeat the question?
My question is, in previously what I gave you the time period and you did the setup slack calculation and hold slack calculation. That's fine. Now I don't know the time period of this circuit, or maybe I have to find what will be the maximum frequency for which this circuit can operate. I have a circuit, I have all the data. I have to find the frequency for this circuit. Do you understand? It's just opposite.
Yes, sir.
Previously frequency was given. Previously frequency was given. Only you have to check whether this frequency having the valuation or not. Now you have the circuit, you have all the data. You have to find what will be the maximum frequency. That will be the target, right? Everybody is running for the speed, power, and area. So you can come up with some frequency. But my intention is, what is the maximum frequency for that this circuit can be operated? That we need to find. Please try this.
Minimum period will be 15 nanoseconds.
Okay.
It should be greater than 50 megahertz.
Frequency should be okay. Let me explain you. So go with the formula, basic thing. Setup flag is equal to required time minus arrival time. Now, first question you should have in your mind: why setup slag? Because setup slag is only depends on the frequency. Hold is not depending on the frequency. If I will take it hold, then I want to be able to reach the frequency. So setup slag I need to take. So setup slag is nothing but required time minus arrival time. And at what condition I will not have the violation? If this slag will be 0 or greater than 0. So my required time minus arrival time should be greater than equal to 0. Yes or no? Now, what are the components we have into T required time? Capture, time period minus T setup. minus arrival time should be greater than 0. Now I have to find the time period. So time period should be, arrival time is negative here, so here it will be positive. Arrival time minus capture plus T setup. So my time period should be greater than equal to this. Any question to understand this formula? Now let's find the time period. What time period we are finding? We are finding the minimum time period so that I will have the maximum frequency. So time period is nothing but what was my arrival time? 26 nanosecond. What is T capture? 15. Setup is 4. 26 minus 15 is 11 nanosecond and plus 4. So it is 15 nanosecond. So my TP should be greater than or equal to 15 nanosecond. Then what will happen? Then I will not have the setup lag. I will not have the setup violation. Guys, are you getting or not? For this circuit, my time period should be greater than equal to 15 nanosecond. If my time period will be greater than equal to 15 nanosecond, this circuit will not have the setup violation. If this circuit will not have the setup violation, it means this circuit can be operated with that frequency. Now,
So can you please means that formula is not clearly visible. How you derived at 15?
okay. I'm going with very basic thing. To don't have the, what is my intention? My circuit can be operated only when, if I will not have the setup violation. If there is a setup violation, then I cannot say that this circuit will be operational with that frequency. Is that statement is clear?
Yes, sir.
Now what will be my formula? Required time minus arrival time is setup lag equal to setup lag. So this setup lag should be greater than equal to 0, isn't it? So required time minus arrival time, this should be greater than equal to 0.
Yes, sir.
Now to solve this inequality, what are the component we have in a required time? So required time, we can say that required time should be greater than equal to arrival time.
Yes, sir.
Now in here we have a T capture plus TP minus T setup should be greater than equal to arrival time. Now we are taking TP this side, we are sending these two guys to this side. Now TP should be greater than equal to arrival time minus T capture plus T setup. Is it clear now?
Yes, sir.
For this, the circuit which we were discussing, for that we know that arrival time was 26, T capture was 15 and T setup is 4. So this will be 15. So my time period should be greater than equal to 15 nanosecond. Either it should be more than 15 nanosecond or it should be equal to 15 nanosecond. If I have to find the maximum frequency for this circuit, which time period we will choose? We will choose greater than 15 or 15. What will be my time period if I have to find the maximum frequency? कुछ तो बोलो यार, तुम लोग तो ऐसे कर रहे हो ना जैसे लग रहा है कि मैं पता नहीं क्या ही पर आ रहा हूँ. Frequency is 1 upon time period. Means my frequency is inversely proportional to time period. If this will decrease, this will increase. So what value you will take? 15 or more than 15?
15.
15.
So to find the maximum frequency, I have to take the minimum time period. Minimum possible time period for which I will not have the setup violation. Is this clear to everyone?
Yes, sir.
Yes, sir.
चलो बढ़िया है, समझ में तो आया. समझ में आया तो we have to do some exercise. Let me find something for you people. Okay. Okay. So can you see my screen?
Yes, sir.
Okay. So in this screen and in this circuit, everything is given. Flip-flop time period, like flip-flop. This TP is nothing but propagation delay for the flip-flop. Okay. This is the clock to Q delay. So the clock to Q delay of D flip-flop, clock to Q delay of JK flip-flop, then AND get propagation delay, OR get propagation delay. This is setup time for D flip-flop. This is the setup time for JK flip-flop. So this is all the information is given. And test net delay is 0. Then first you have to find like how many raise to raise path you have into this design. Can anyone say that how many raise to raise path we have?
4.
How many? I was hearing some number. Can you repeat again?
4.
Okay, one answer is 4. What about other?
2 paths.
Two, sir.
Okay, 2. Another answer. Okay, let me explain. So if I'm moving from this flip flop to this flip flop, I can find that there is a path. This is going through like this. This is one path. I see that there is a path which is going from Q bar to this gate, then it's going to the K. Right? Any other path from this flip flop to this flip flop? No, right? Only these two paths. Now let's check from this flip flop. One path is going from this guy to this guy and then D. The third path. And another path is from here. Only dots are the connection. So we reached here. Again, this guy is going to the same flip flop. So for this path, this flip flop is acting as a launch flop, and this flop is again acting as a capture flop. That's a kind of ring counter or something which we create in a digital design. No? So same with one inverter is creating the opposite waveform like that. So Johnson counter, your ring counter, those things can be created, right? So in that way, if I will assume this same flip flop acting as a launch and capture. So total for raised to this path for this circuit is 4. Now you know that we have a 4 path, and I have to find the maximum frequency for this circuit. I have to find the maximum frequency for this circuit. How we will find it? To find the maximum frequency, we have to find the minimum time period for which this circuit will not have the setup violation. Is this statement is clear to everyone? Yes or no?
Yes, yes, sir.
To find the maximum frequency, I have to find the minimum time period for which I will not have the setup violation among all the rest of this path. So I should have a time period. Using that time period, all the path of this, all the 4 path which we have in this circuit should not have the setup violation. So can you find the time period, guys? Please find the time period. It's 12:24. I'm giving you 6 minutes. I will be back by 12:30. Meanwhile, you find the time period for this circuit which will not have the setup violation, and that will be leads to your maximum frequency. Okay. चलो शुरू हो जाओ. So what is time period? Minimum time period? Are you able to get it?
So we have analyzed two parts. Still two more parts is there. Maybe
Oh,
in another 5 minutes we'll do it.
47.
47.
Sir, 47.
30,
40,
30 nanosecond.
40 nanosecond.
30.
30 nanosecond. Okay. So 30, 40, 45, 47. We have several answers. Okay, we'll check. So as I already explained, from Q1 to Q1, we don't have any path. I mean to say that Q1 to Q1, like same D flip-flop is not acting as a launch and capture. So from same D to D, there is no any path. Q1 to Q2, we have one path, that is this. Directly it's going to the JK. This Q1 to JK. And in this path, the delay is no this delay, only D flip-flop delay, that is called 20 nanosecond. And T setup. Formula also we derived a formula, right? What was the formula? Time period should be greater than equal to arrival time plus T setup minus T capture. And here by T capture is there is no any clock delay. So this is 0. So arrival time plus setup time. Arrival time is nothing but only this flip-flop delay. That is called the D flip-flop delay. That is 20 nanosecond. 20 plus 10 is 30 nanosecond. Okay. This is for path 1. We have one more path from Q1 to Q2. This is D flip-flop plus AND gate plus setup time. So D flip-flop AND gate delay is 12 nanosecond and setup is 10 nanosecond. Altogether is 42 nanosecond. So this path is giving a delay of, not a delay, time period required for this path is 30 nanosecond. Time period required for this path is 42 nanosecond. Let's check for the other paths. Okay, so for this path, which is going from JK to D, that is JK flip-flop plus this OR gate, then setup for this D. That is altogether as 40 nanosecond. Q to Q2. It means same flip-flop acting as a launch and same is acting as a flip-flop, like this path. So JK flip-flop propagation delay is 25 nanosecond. AND gate delay is 12 nanosecond. And setup is 10 nanosecond. All together is 47 nanosecond. So we have 4 timing. We have 4 time period: 30 nanosecond, 42 nanosecond, 40 nanosecond, and 47 nanosecond. Now, can you tell me what will be the time period for this circuit which can be used for the frequency?
So 47 need to be used since if we take a maximum time, it will be the operating frequency will be the minimum operating frequency. So the path 4 has uh, maximum time, so that is the minimum frequency. Without any violation, the 4 path needs to be active. Then we need to take a 47 nanosecond. So without
So
any
you mean to
violation,
say that
4 path.
you will take 47 nanosecond. You will take 47 nanosecond. So if I'll take 47 nanosecond, then my frequency will be minimum, right?
Yes. So the max. So if we take a maximum frequency, the remaining these spots will be affected, right?
But my intention is, what is my intention? I have to find a
So
maximum
then we need
frequency
to,
for this circuit.
yeah, 30 nanoseconds. So we need to take that in.
Okay. Any other opinion?
Sir, 47 nanoseconds.
What about this 42 and 40 and 42? No one is bothering about this 40 and 42. Everybody is either they are going to this place and they are coming to this place, right? Okay. So why 47, guys?
Sir, because if we take less than 47, then the fourth path will be, setup violation.
Okay.
So we can't take a time period less than 47. We have to take time period at least 47 nanoseconds.
That's correct. That's correct. So I have to select a time period for which I should not have the setup violation among all the paths. So if I am taking 30, I can get the more frequency, but that frequency is not the correct frequency. I will get the more frequency, but in that frequency, these three paths will have the violation. These three paths will have the violation, and if it's a violation, then there is no any significance to design a frequency. My intention is to design a maximum frequency such that that circuit will be operational. I can achieve the maximum frequency, but my circuit is not working. It is not operational because these three paths having the violation. To doesn't have any violation and have the frequency also, this is the time period for which I will have the frequency, and in that frequency these three paths will also not have the violation, and my circuit will be operational. So if I have to find the minimum time period and maximum frequency for this circuit, that will be either 47 or greater than 47. Correct? समझ में आया कि नहीं आया?
Understood, sir. Yes.
Good. Can you see my screen?
Yes, sir.
Can you find the maximum operational frequency for this circuit? Find the F max operational for given circuit.
So 16.
What is maximum frequency?
16 time period maximum. We have to consider 16 nanoseconds.
Okay. Any other answer?
22 nanoseconds.
22.
16.
Any other answer? 16. 2 people. Or good? Kuch nahi. Okay, let's see. So can you guys tell me like how many raised to raise path we have in the circuit?
3, sir.
3. So everybody is agree with this? We have 3 raised to raise path.
2, sir. 2.
Okay. So you are not agree. You are with 2 only. Okay. Let's see. If we'll see, we have a path from A to C. This is one path. We have path from A to B. This is another path. And we have a path from B to C. So I see there is 3 paths. Is this clear?
Yes, sir.
So did you find a path? Did you find the time period for each path? Okay, let's name it. This is the first one. This is second one. This is third one. Okay. So for the first path, TW should be greater than equal to what? This clock to Q delay will be the arrival time. So 9 plus setup time for the capture flop, that is 2. Anything else? We are writing for first one. So this should be greater than, so this should be 11 nanosecond. TW2, we are looking for this path. Clock to Q delay is for flip-flop 1, that is 10 nanosecond. Plus T setup for this flip-flop. We have a combinational delay also. So that is 4 nanosecond. Setup is 2 nanosecond. That is 16 nanosecond. 10, 4, 2. Let's go for A to C path. That is third path. Clock to Q delay 9 nanosecond. Combinational delay is 4 nanosecond. Setup delay for C flip-flop, capture flop is 2 nanosecond. That is 15 nanosecond. So which time period we will take to find the frequency?
Sixteen.
So 16 for 16 nanosecond, my all the path will satisfy the criteria and any path will not have the violation. Correct? So 16 nanosecond will be the minimum time period for which this circuit will be operational. Is this fine for everyone or any confusion? कुछ confusion है तो पूछ लो.
Sir, in third part, you said the TPD of combinational logic you take, but the other input is coming from this path to combinational logic. Then how, which way of choose?
There can be many path. There can be many path which is coming. You have to only focus the path which is traveling you from launch to capture. That's it. You no need to bother about how many paths are coming to these people. Maybe you have 4 input AND gate, right? 4 input AND gate. but you are traveling from third input, the output, and then you are going to the capture end. So you are only bothered about this arc, A, B, C, D, C to Y. This timing arc you are only responsible, not even this. Rest about leave the rest people. This input can come from someplace. This input can come from someplace. This input can come from someplace. I only bothered about this thing. Understand?
Yes, sir.
So let's summarize what we were doing. To find the maximum frequency, what is my first step? My first step to find the total number of rails to rails path. Correct? Second step, find the time period for each path for not having setup violation. Correct? For each individual path, I have to find the time period. Among all the time period, maximum time period will be chosen to calculate maximum frequency. Why I told maximum time period? Because maximum time period, if we will take, then my other paths will also satisfy with the setup violation. So if we will pick out the maximum time period among all the paths, which will give the maximum frequency, that will be the operational frequency of the design. Any confusion in this, guys? कुछ कंफ्यूजन है तो पूछ लो, कुछ डाउट है तो पूछ लो, कुछ समझ में नहीं आया तो पूछ लो, और ये इससे अगर कुछ भी नहीं है तो तुम बिगड़ जाओ, मैं बिगड़ जाता हूँ. Any question, guys? These PPTs are already shared. You can check with the admin people. Will help you out. Okay. I think there is no any question, so we can wind up the session today. Guys, be safe, because you know how corona is spreading. So be safe. We have to save. We have to be, we should not go out in any case. Even if it's a big emergency, then only we should go out. Otherwise, if you are in home, you are safe. If you are going out, you don't know from where you will get the virus, because that is now we have a community transfer, right? So the only thing is we have to be take care ourselves and our parents, our family members, whatever we can. So be safe, guys. We'll meet on the next week. Okay.
Yeah, thank you.
Okay,
Thank you,
sir. Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, guys. Bye bye. See you in the next week.
Thank you, sir.